analyze the truss shown in figure by using the flexibility matrix method. Here A and D are the two supports, both are hinges. A to D is 3 meter, A to B 4 meter. At B it is subjected to 100 Newton force. B to C is another member. At C, at joint, it is subjected to 120 Newton force towards right side. C to D is 4 meter. B to D is connected diagonally and A to C is connected diagonally by two members. Here, by observing the figure, the total number of members are 4 plus 2, that is 6, and the number of joints are A, B, C, D, number of joints are 4. First, we have to find out the angle theta. Here, by observing the diagram, AC becomes hypotenuse, DC becomes opposite side, ED becomes adjacent side. Similarly, in the other triangle, angle ADB is also theta. AB is opposite side, AD is adjacent side, BD becomes hypotenuse. Then tan theta equals opposite side divided by adjacent side. Opposite side is 4 meter, adjacent side is 3 meter. Therefore, theta equals tan inverse of 4 by 3. Or we can calculate sin theta equals by Pythagoras theorem. The closing line becomes ECR BD. The diagonals are 5 meter each. Then sin theta equals 4 by 5. Cos theta equals 3 by 5. You can calculate like that also. Then the first step is to calculate the degree of indeterminacy or degree of redundancy. Here the total number of support reactions are at both the end A and D, both are hinges. Hence the number of reaction components are 2 at each end. 2 into 2, that is 4 number of unknowns. The number of members M equals 6, number of joints J equals 4. Therefore, the degree of redundancy or degree of indeterminacy is given by M minus in the bracket 2 or minus J. M equals 6 by substituting the values inside the minus, inside of the bracket 2 into 4 minus 4 number of unknowns, that equals 2 into 4 is 8 minus 4, that is 4. 6 minus 4, that is 2. Here we have to consider any two members as the redundants. Here now we will consider the horizontal reaction component at hinge D as one of the redundant. Similarly, the force in the member BD as another redundants. Then the second step is to find the displacement due to the loads. First we have to remove the redundant reactions, then show only the applied loads to make the structure statically determinate and stable structure. Here in the figure shown, we have removed the force in the member BD, and the instead of at D, instead of hinge, we have shown a roller. Then that is statically determinate and stable structure. First, find out the support reactions by applying the equilibrium equations. Summation of the moments of all the forces about A equals 0. That is 120 into 4. That one is the clockwise moment. PD, that is the reaction at the roller, which is normal to the direction of the roller. That one is that is PD into 3. Therefore, VD equals 120 into 4 by 3. After solving, you will get 160 Newton acting vertically upward. Now by applying the equilibrium equation, summation of V equals 0, therefore VA equals, that is 100 is acting in downward direction, 160 is acting in upward direction. Total upward forces equals total downward force. Therefore, VA becomes 60 Newton in downward direction as shown in figure. Then summation of H equals 0. Here, by applying that equilibrium equation, HA equals 120 Newton towards left side. Now, to calculate by equilibrium of joint, we have to calculate the forces in all the members by equilibrium of joint D. At joint D, summation of V equals 0. Then the force in the member DC, force in the member DC equals 160 Newton, that is compressive. Summation of H equals 0. Then the force in the member DA is 0. Here, by observing this at joint, at this joint, here the reaction VD is acting along one of the member. Therefore, the force in this member is 160 Newton. Then the force in this member is 0. Summation of H equals 0. Similarly, by equilibrium of joint B, here at joint B, the force is acting along one of the member. The force in the member BA equals 100 Newton, which is compressive, and the force in the member BC is 0 as shown in figure. Similarly, by the equilibrium of the joint, here now we know this force is 0, this force is 100. Then by resolving the forces along vertical and horizontal direction, then we can assume this force as the tensile force. The force in the member AC sine theta is the component along vertical direction, cos theta along the horizontal direction. Then by applying the equilibrium equation, by equilibrium of the joint, summation of the forces in horizontal direction equals 0. Therefore, the force in the member AC, that is by resolving F AC cos theta, F AC cos theta equals 120 Newton. Here we have calculated cos theta equals 3 by 5. Cos theta equals 3 by 5. Therefore, the force in the member AC equals, that is 120 into 5 by 3. That one is 200 Newton, that is tensile. Now we have got the values of the forces in the different members. This one is 100, this one is 200, this one is 160, and the force in these two horizontal members is 0. After getting the values of the forces in the members, that is, now we can get, if you want to can verify, we can check. Then the third step is remove all the forces, external forces. Here we have considered two number of redundants. One is the force in the member BD and another one is the horizontal reaction component. Here, first remove all the external forces and apply a unit load along one of the redundant, that is BD. The force in the member BD is 1 Newton as shown in figure. Now, after applying 1 Newton along the redundant BD, first we have to find the forces in all the members. Here at joint B, resolve the forces along x and y axis or along horizontal and vertical direction by applying the equilibrium equation. Summation of V equals 0. Here, that is the force in the member due to the unit load, that is UBA, that one is UBA minus UBA minus 1 cos theta, 1 cos theta. Here you will get UBA equals minus 0.6 Newton. Similarly, summation of horizontal forces equals 0. UBC, that one is UBC, that is we have assumed this tensile as tensile plus 1 sin theta, therefore UBC equals minus 0.8 Newton. Here the forces are, here this one is assumed as tensile, but that is we have got negative sign. This and this are both are compressive in nature or acting towards the joint. One is 0.8 and one is 0.6 Newton respectively. Then at joint C, summation of H equals 0. Summation of H equals 0, that is the force in the member due to unit load along the redundant, that is FEC cos theta or UEC cos theta. By resolving this force, then that one plus the unit load along the member BC due to the force in the member due to the unit load, that is UBC, that equals 0. Therefore, UAC equals 0.8 by 0.6. Here you will get the force in the member due to unit load along the redundant BD, that one is 1.33 Newton as shown in figure. Then summation of V equals 0. Here you will get 1.33 sin theta, that is negative, minus force in the member due to unit load in the redundant BD, that equals 0. Therefore, UCD, that is unit load in member CD, equals minus 0.1067 Newton as shown in figure. This one is also compressive. Then after getting the value of the forces, then at joint D, then summation of H equals 0. Here by resolving the forces summation of H equals 0, that is minus 1 sin theta minus the force in the member CD due to the unit load along the redundant BD, then that equals 0. Therefore, the force in the member in CD due to the unit load along the redundant BD, that one is 1.067 Newton, that is FED equals 0.8 Newton. Then apply afterwards, after getting the forces in the members due to the unit load along the first redundant, then you will get the forces in the various members. Now we can apply the unit load along the redundant 2. Then here, now if you apply the unit load along the redundant 2, this one is the unit load along redundant 2, the forces in all these members are 0. Here, since the force is acting along one of the member, the force due to the unit load along the redundant 2, that one is equals the force in this member, that is A to D. Then this one is here, this one is towards right side. The force direction of this force is to the left side. Similarly here also the force in this member is to the right side. Then the support reaction at A in horizontal direction, that becomes 1 Newton. Here now we can tabulate all the values, that is FED is 1 Newton, that is tensile. Now we can tabulate the values, that is here first we have to write the member, first member AB, BC, CD, DA, AC, BD. EB equals here A to B is 4 meter, B to C that is 3 meter, C to D that is 4 meter, D to A that is 3 meter. The diagonal AC is 5 meter, diagonal BD is 5 meter. The force in the members due to the applied loads, the force in the member AB is that is compressive. In the previous table, in the previous diagram we have got that is minus 100 Newton. The force in the member BC horizontal member is 0. Force in the vertical member, another vertical member that is compressive, that is minus 160. Force in the horizontal member at the bottom, that is 0. Force in the diagonal member, that is 200 Newton, that is tensile. The force in the member BD as the redundant, that is 0. Here in the previous drawing we have removed that as the redundant, and due to then the force in the members due to the unit load along the diagonal BD. Here these are the values as per the above diagram. Here force in the member EB due to the unit load along BD, that is minus 0.6. In the member BC, that is minus 0.8. Here these are the values of the forces in the members due to the unit load applied along the first redundant, that is second one is minus 0.8, third one is CD, that is minus 1.067, DA, that is minus 0.8, EC along the diagonal, that is 1.33, that is tensile, and along BD, that is we have applied the unit load along the redundant BD. Then due to the unit load along the redundant 2, that is all the forces in all the members is 0 except the force in the member ADRDA, that is 1, that is tensile. And then now we can apply the unit load method, that is F U1L by AE, that is summation of F U1L by AE. Here U1 you know, F you know, length you know, AE is we can assume that as constant, that is same throughout the all the members. Then here by calculation of the FU1L by AE, for the first member that is 240, for the second member F is 0, for the third member that is 682.88, for the fourth member F is 0, for the fifth member 1333.33, for the last member that is F is 0. Therefore the summation of FU1L by AE is 2256.21 by AE. Similarly, this is due to the first unit load along the redundant BD. Then second one along the redundant 2, that is only one is positive, but here the force in the member is 0. Therefore all the forces, all the values of Fu to L by AE is 0. The summation of Fu to L by AE is 0. Then here to get the displacement due to the unit load along the redundants, that is U1 square L by AE. Here for the first member that is 1.44, second member 1.92, third member 4.55, fifth member that is 1.92, for the next member that is 8.89, for the last member that is 5. Here by adding all these things to get summation of u1 square L by AE. That one is the flexibility element F11 or the displacement at 1 due to the load applied along the first redundant, that is 23.72. Then u2 square L by AE. Here u2 square L by AE, here only one member is subjected to a load of 1 kilonewton, 1 newton. Then this one is 3. Then the remaining things are 0. Here u2 square L by AE, summation of those things, that is we will get the second flexibility element, that is F22. F22, that one is the displacement at 2 due to the unit load acting along the redundant 2. Then to get the displacement element or the flexibility element at 1 due to the load applied at 2, or the displacement at 2 due to the load applied at 1, delta 1 2 or delta 2 1, that is F21 or F12. Here by using the u1 u2 L by AE, here only in one of the member you will get minus 2.4 by taking the summation, that is delta 1 2 or delta 2 1 equal summation of u1 u2 L by AE, that one is minus 2.4 as shown in the table. Now we can get the flexibility elements. Here we know that the redundant forces are, there are two redundants. One is the force in the member BD and another one is the redundant horizontal reaction component at hinge D. Here these two are the redundant reaction. Then here AE is constant. The flexibility matrix method, that is flexibility matrix, is given by here inverse of this one, that is 1 over AE. Inverse of 1 over AE is, that is AE. Then here the elements just now we have calculated, that is summation of u1 f1 square summation of u1 square L by AE, that is 23.72. Then summation of u1 u2 L by AE, that is 2.4 minus 2.4 minus 2.4 for the second. Here this one is minus 2.4, this one is also minus 2.4, that is then F22, that is displacement at 2 due to the load applied at 2, that one is summation of u2 square L by AE, that one is 3. Then the displacement due to the loads, that one is summation of F u1 L by AE, that one is 2256.21. Then summation of u2 L by AE, that one is 0. Here these two are the displacement component, displacement due to the loads at coordinates 1 and 2 respectively, that divided by AE. Here the displacement due to the settlement and sinking of the support is 0. Hence 0 minus this one is minus 1 is common, minus 1 over AE is common. Then here after simplification you will get the displacement and the redundant values are, the first redundant is minus 1 or 3.49, the second redundant is minus 82.796. Here these are the values of the redundants 1 and 2 respectively. Then the final forces in each members are given by the force in the member, any member equals F equals u1 into p1 plus u2 into p2. Here the force in the member, that one is minus 100 due to the applied load. By removing the redundants what we have calculated, that is the force in the member AB is 100. Then the redundant, the force in the member due to the unit load, first unit load, that is minus 0.6, the redundant value, that is minus 103.49, plus the force in the member due to the unit load, that is 0. The second redundant is 82.796. Here this term is 0. After simplification, the force in the member AB is 37.906 Newton, that is negative, means that is compression. Then the force in the second member BC, the force in the member due to the applied load after removing the redundants, that is 0. Then the force in the member due to the unit load acting along the redundant BD, that is minus 0.8, that we have calculated. Then the redundant force in the member P1 is minus 103.49 minus the force in the member due to the unit load acting along the redundant 2, that is 0, into the second redundant value is P2. Here this one is 0. After simplification, here this will get minus into minus plus, that is 82.792 Newton, that is tensile. Then the force in the member CD, force in the member CD, that is minus 160, one of the vertical member, that is force in the member due to the applied load after removing the redundants, that is minus 160. Then the force in the member due to the unit load acting along the diagonal BD, that is minus 1.067, into the first redundant value is minus 103.49. Then due to the second um, due to the second redundant, the force in the member due to the second redundant, that is 0, into second redundant value is 82.796. This becomes 0. There is minus into minus plus. Then this one is minus 49.58, that is compression. Then the force in the member DA, force in the member, horizontal member DA at the bottom chord member, that one is 0. The force in the member is 0. Unit load due to the force in the member due to unit load along the diagonal BD, that is 0.8, into the first redundant value, that is 103.49, minus into minus, that becomes plus. Then 1 into minus 82.796, that is the force in the member due to the unit load acting along the redundant 2, this becomes 0. Then the force in the member AC, that is one of the diagonal, that one is the force in the members due to the applied load, that is 200. The first redundant, that is unit load, force in the member due to the unit load applied along the BD, that is minus 1.33, into the first redundant value is 103.49, that one equals 62.019 Newton, that is tensile. Then the force in the member BD, that one is minus 0, that is one of the redundant, due to the force applied along the redundant 2 along the diagonal BD, that is minus 1 into 103.49, that one is minus 103.49 Newton is the forces. We will continue in the next video.